Software as a service is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. It is sometimes referred to as on-demand software. SaaS is typically accessed by users using a thin client via a web browser. SaaS has become a common delivery model for many business applications, including office and messaging software, DBMS software, management software, CAD software, development software, gamification, virtualization, accounting, collaboration, customer relationship management, management information systems, enterprise resource planning, invoicing, human resource management, content management and service desk management. SaaS has been incorporated into the strategy of all leading enterprise software companies. One of the biggest selling points for these companies is the potential to reduce IT support costs by outsourcing hardware and software maintenance and support to the SaaS provider. According to a Gartner Group estimate, SaaS sales in 2010 reached $10 billion, and were projected to increase to $12.1 billion in 2011, up 20.7% from 2010. Gartner Group estimates that SaaS revenue will be more than double its 2010 numbers by 2015 and reach a projected $21.3 billion. Customer relationship management continues to be the largest market for SaaS. SaaS revenue within the CRM market was forecast to reach $3.8 billion in 2011, up from $3.2 billion in 2010. The term software as a service is considered to be part of the nomenclature of cloud computing, along with infrastructure as a service, platform as a service, desktop as a service, back-end as a service, and information technology management as a service. History: centralized hosting of business applications dates back to the 1960s. Starting in the decade, IBM and other mainframe providers conducted a service bureau business, often referred to as time-sharing or utility computing. Such services included offering computing power and database storage to banks and other large organizations from their worldwide data centers. The expansion of the Internet during the 1990s brought about a new class of centralized computing, called application service providers. ASPs provided businesses with the service of hosting and managing specialized business applications, with the goal of reducing costs through central administration and through the solution provider's specialization in a particular business application. Two of the world's pioneers and largest ASPs were USI, which was headquartered in the Washington, D.C. area, and FutureLink Corporation, headquartered in Orange County, California. Software as a service essentially extends the idea of the ASP model. The term software as a service, however, is commonly used in more specific settings, whereas most initial ASPs focused on managing and hosting third-party independent software vendors' software. As of 2012, SaaS vendors typically develop and manage their own software. Whereas many initial ASPs offered more traditional client-server applications, which require installation of software on users' personal computers, SaaS solutions of today rely predominantly on the web and only require an internet browser to use. Whereas the software architecture used by most initial ASPs mandated maintaining a separate instance of the application for each business, as of 2012 SaaS solutions normally utilize a multi-tenant architecture, in which the application serves multiple businesses and users, and partitions its data accordingly. The SaaS acronym allegedly first appeared in an article called Strategic Backgrounder, Software as a Service, internally published in February 2001 by the Software and Information Industry Association's e-business division. DBAS has emerged as a sub-variety of SaaS. Distribution: the cloud model has no physical need for indirect distribution since it is not distributed physically and is deployed almost instantaneously. The first wave of SaaS companies built their own economic model without including partner remuneration in their pricing structure. It has not been easy for traditional software publishers to enter into the SaaS model. Firstly, because the SaaS model does not bring them the same income structure. Secondly, because continuing to work with the distribution network was decreasing their profit margins and was damaging to the competitiveness of their product pricing. Today a landscape is taking shape with SaaS and managed service players who combine the indirect sales model with their own existing business model, and those who seek to redefine their role within the 3.0 IT economy. Pricing: unlike traditional software which is conventionally sold as a perpetual license with an upfront cost, SaaS providers generally price applications using a subscription fee, most commonly a monthly fee or an annual fee. Consequently, the initial setup cost for SaaS is typically lower than the equivalent enterprise software. SaaS vendors typically price their applications based on some usage parameters, such as the number of users using the application. However, because in a SaaS environment customers' data resides with the SaaS vendor, opportunities also exist to charge per transaction, event, or other unit of value. The relatively low cost for user provisioning in a multi-tenant environment enables some SaaS vendors to offer applications using the freemium model. In this model, a free service is made available with limited functionality or scope, and fees are charged for enhanced functionality or larger scope. Some other SaaS applications are completely free to users, with revenue being derived from alternate sources such as advertising. A key driver of SaaS growth is SaaS vendors' ability to provide a price that is competitive with on-premises software. This is consistent with the traditional rationale for outsourcing IT systems, which involves applying economies of scale to application operation, that is, an outside service provider may be able to offer better, cheaper, more reliable applications. Architecture: the vast majority of SaaS solutions are based on a multi-tenant architecture. With this model, a single version of the application, with a single configuration, is used for all customers. To support scalability, the application is installed on multiple machines. In some cases, a second version of the application is set up to offer a select group of customers with access to pre-release versions of the applications for testing purposes. This is contrasted with traditional software, where multiple physical copies of the software are each potentially of a different version, with a potentially different configuration, and often customized or installed across various customer sites. While an exception rather than the norm, some SaaS solutions do not use multi-tenancy, or use other mechanisms such as virtualization to cost-effectively manage a large number of customers in place of multi-tenancy. Whether multi-tenancy is a necessary component for software as a service is a topic of controversy. Characteristics: while not all software as a service applications share all traits, the characteristics below are common among many SaaS applications. Configuration and customization: SaaS applications similarly support what is traditionally known as application customization. In other words, like traditional enterprise software, a single customer can alter the set of configuration options that affect its functionality and look and feel. Each customer may have its own settings for the configuration options. The application can be customized to the degree it was designed for based on a set of predefined configuration options. For example, to support customers' common need to change an application's look and feel so that the application appears to be having the customer's brand, many SaaS applications let customers provide a custom logo and sometimes a set of custom colors. The customer cannot, however, change the page layout unless such an option was designed for. Accelerated feature delivery: SaaS applications are often updated more frequently than traditional software, in many cases on a weekly or monthly basis. This is enabled by several factors. The application is hosted centrally, so an update is decided and executed by the provider, not by customers. The application only has a single configuration, making development testing faster. The application vendor has access to all customer data, expediting design and regression testing. The solution provider has access to user behavior within the application, making it easier to identify areas worthy of improvement. Accelerated feature delivery is further enabled by agile software development methodologies. Such methodologies, which have evolved in the mid-1990s, provide a set of software development tools and practices to support frequent software releases. Open integration protocols: Since SaaS applications cannot access a company's internal systems, they predominantly offer integration protocols and application programming interfaces that operate over a wide area network. Typically, these are protocols based on HTTP, REST, SOAP and JSON. The ubiquity of SaaS applications and other Internet services and the standardization of their API technology has spawned development of MASUPs, which are lightweight applications that combine data, presentation and functionality from multiple services, creating a compound service. MASUPs further differentiate SaaS applications from on-premises software as the latter cannot be easily integrated outside a company's firewall. Collaborative functionality, inspired by the success of online social networks and other so-called Web 2.0 functionality, many SaaS applications offer features that let its users collaborate and share information. For example, many project management applications delivered in the SaaS model offer a Euro in addition to traditional project planning functionality. Euro collaboration features letting users comment on tasks and plans and share documents within and outside an organization. Several other SaaS applications let users vote on and offer new feature ideas. While some collaboration-related functionality is also integrated into on-premises software, collaboration between users or different customers is only possible with centrally hosted software. Adoption drivers. Several important changes to the software market and technology landscape have facilitated acceptance and growth of SaaS solutions. The growing use of web-based user interfaces by applications, along with a proliferation of associated practices, continuously decreased the need for traditional client-server applications. Consequently, traditional software vendors' investment in software based on fat clients has become a disadvantage, opening the door for new software vendors offering a user experience perceived as more modern. The standardization of web page technologies, the increasing popularity of web development as a practice, and the introduction and ubiquity of web application frameworks like Ruby on Rails or languages like PHP gradually reduced the cost of developing new SaaS solutions, and enabled new solution providers to come up with competitive solutions, challenging traditional vendors. The increasing penetration of broadband Internet access enabled remote centrally hosted applications to offer speed comparable to on-premises software. The standardization of the HTTPS protocol as part of the web stack provided universally available lightweight security that is sufficient for most everyday applications. The introduction and wide acceptance of lightweight integration protocols such as REST and SOAP enabled affordable integration between SaaS applications with internal applications over wide area networks and with other SaaS applications. Adoption challenges. Some limitations slow down the acceptance of SaaS and prohibit it from being used in some cases, since data are being stored on the vendor Euro unregistered trademark S servers. Data security becomes an issue. SaaS applications are hosted in the cloud, far away from the application users. This introduces latency into the environment. So, for example, the SaaS model is not suitable for applications that demand response times in the milliseconds. Multi-tenant architectures, which drive cost efficiency for SaaS solution providers, limit customization of applications for large clients, inhibiting such applications from being used in scenarios for which such customization is necessary. Some business applications require access to or integration with customers' current data. When such data are large in volume or sensitive, integrating them with remotely hosted software can be costly or risky, or can conflict with data governance regulations. Constitutional search-seizure warrant laws do not protect all forms of SaaS dynamically stored data. The end result is that a link is added to the chain of security where access to the data, and, by extension, misuse of these data, are limited only by the assumed honesty of third parties or government agencies able to access the data on their own recognizance. Switching SaaS vendors may involve the slow and difficult task of transferring very large data files over the Internet. Organizations that adopt SaaS may find they are forced into adopting new versions, which might result in unforeseen training costs or an increase in probability that a user might make an error. relying on an Internet connection means that data are transferred to and from a SaaS firm at Internet speeds, rather than the potentially higher speeds of a firm unregistered trademark S internal network. The standard model also has limitations: compatibility with hardware, other software, and operating systems. Licensing and compliance problems. Maintenance, support, and patch revision processes. Emerging trends. As a result of widespread fragmentation in the SaaS provider space, there is an emerging trend towards the development of SaaS integration platforms. These SIPs allow subscribers to access multiple SaaS applications through a common platform. They also offer new application developers an opportunity to quickly develop and deploy new applications. This trend is being referred to as the third wave in software adoption, where SaaS moves beyond standalone applications to become a comprehensive platform. Zoho and Sutisoft are two companies that offer comprehensive SIPs today. Several other industry players, including Salesforce, Microsoft, and Oracle, are aggressively developing similar integration platforms. Data escrow. Software as a service. Data escrow is the process of keeping a copy of critical software as a service application data with an independent third party. Similar to source code escrow, where critical software source code is stored with an independent third party, SaaS data escrow is the same logic applied to the data within a SaaS application. It allows companies to protect and ensure all the data that reside within SaaS applications, protecting against data loss. There are many and varied reasons for considering SaaS data escrow, including concerns about vendor bankruptcy, unplanned service outages, and potential data loss or corruption. Many businesses are also keen to ensure that they are complying with their own data governance standards or want improved reporting and business analytics against their SaaS data. A research conducted by Clearbase Software Limited into the growth of SaaS showed that 85% of the participants wanted to take a copy of their SaaS data. A third of these participants wanted a copy on a daily basis. Criticism. One notable criticism of SaaS comes from Richard Stallman of the Free Software Foundation, referring to it as service as a software substitute. He considers the use of SaaS to be a violation of the principles of free software. According to Stallman, with SaaS, the users do not have a copy of the executable file, it is on the server, where the users can't see or touch it. Thus it is impossible for them to ascertain what it really does, and impossible to change it. SaaS inherently gives the server operator the power to change the software in use, or the user's data being operated on. See also, servicizing, cloud-based integration, application service provider, references.